Hello and welcome. In this video we're going to be discussing how to solve a mixture problem involving percentages. But before we begin with this problem, let's start with a background problem. So suppose I walked out to the parking lot and found that 30% of the cars are green. Suppose also that I counted and I found that there were 50 cars. Notice the percentage doesn't really tell me how many of those 50 cars are green, but what if I wanted to figure that out? How would I do it? Well, if I know how many total cars there are, I can take my 30%, turn it into a decimal, and then I can multiply that by the total number of cars that I have, and the answer should tell me the number of cars that are green. So if I take the percent that are green, and I multiply it by the total number of cars, it should tell me the number out of that total that are green. So it should tell me how many green cars I have. So we're going to use that idea on the problem that we're going to look at. So let's just begin by reading this problem. Suppose two factories are making TV panels. Yesterday, Plant A produced 4 times as many panels as Plant B. 3% of the panels from Plant A and 2% of the panels from Plant B were defective. If together there were 980 defective panels, how many panels did Plant B produce? So if we think back to the car situation, I kind of see something similar. So we have these two plants producing panels. A percentage of them are defective. So if I want to know how many are defective, I can use that same type of formula that we found before. So the formula looked like this. Percent defective times the total number of panels equals the number of defective panels. So what you'll notice in this problem also is that we have two different plants producing panels. So what I'm going to do is organize my information in a table. So I've got plant A, I've got plant B, and then I'm also going to have a third row for any information that pertains to plant A and plant B. So now I'm just going to make a table out of what I have. And I'm going to try to fill in as much of the table as I can. Well, one of the things that they mentioned was that 3% of the panels from Plant A and 2% of the panels from Plant B were defective. So percent defective we now know is, I'm going to write that in as 0.03, writing it as decimal right away, and 0.02. Total panels produced, do they give us that information? Well, sort of. They kind of tell us that yesterday, Plant A produced 4 times as many panels as Plant B. And then if you look at what they're asking for, they're saying, how many panels did Plant B produce? So for the number of panels that Plant B produced, I'm going to call that X. And then if we go back to that first sentence, if the number of panels that Plant B produced is X, it says Plant A produced 4 times as many panels as Plant B. So if Plant B produced X panels, Plant A must have produced 4 times that number, or we could write that in as 4X. They give us one other piece of information in here. They tell me that together, 980 defective panels were produced. So where would that go? Well, it's going to go in my defective panel column, but it's going to go in my combined row. So I know that 980 defective panels were produced. Okay, so now I want to come up with a formula for just the number of defective panels produced at Plant A. Well, I would take my percentage times the number of panels produced at Plant A, and that would give me 4x times 0.03. Similarly, the number of defective panels that Plant B is producing would be 0.02 times x. And now what I know is that the number of defective panels produced at Plant A plus the number of defective panels produced at Plant B has to equal 980, because that's what this guy represented. It represented the number of defective panels produced at A plus the number of defective panels that were produced at plant B. So these two guys have to add together to equal 980, and that's my equation. So now if we solve that equation, 0.03 times 4x is 0.12x, plus 0.02x equals 980. Combine those terms, gives me 0.14x equals 980. Divide both sides by 0.14. And that gives me x equals 7,000. And that is my answer because x represented exactly what I was interested in finding, which was the number of panels that plant B produced. So my answer is 7,000. Okay, so here's another one for you to try. Pause the video and then restart after you've given it a shot. Okay, so this one is really similar to the last one. I want to start by coming up with a formula. So you'll notice they give me percent alcohol, and then we're basically using milliliters of a solution, and we want to come up with milliliters of pure alcohol. So again, this is just like the car situation. If I take the percent of my solution that's alcohol, and I multiply that by the total amount of milliliters in the solution, that should give me the number of milliliters that are pure alcohol. And just like the last one, we have two different solutions. So I've got solution A and I've got solution B. And then I'm going to do a row for any combined information. And then I'm just going to make a table out of this. And if we fill things in, well, first thing I see is that solution A is 11% alcohol, solution B is 15% alcohol. Okay, total milliliters of solution, if we look back, well, they don't really tell us, but notice if we look at the question part, it says how much of solution A was used. So I'm going to call solution A X. And then if we look back at that second sentence, it says 100 milliliters less of solution A was used than solution B. So what I know is that X is 100 less than solution B. In other words, they used 100 more of solution B than they used of solution A. So that means I could write the total milliliters of solution B as X plus 100. It's whatever they used for A plus an additional 100. They give me one other piece of information here, which is they tell me how many milliliters of pure alcohol I'm producing between the two. So that 67 is going to go down here in my combined row. And now I want to come up with an expression for how much pure alcohol I'm getting from each solution individually. So the first one, 0.11 times X, is the amount of pure alcohol from solution A. And the second one, 0.15 times X plus 100, is the amount of pure alcohol I'm getting from solution B. So what I know is that if I take the pure alcohol that I'm getting from solution A, plus the pure alcohol I'm getting from solution B, that should equal 67. So just like before, these two guys should equal, if I add them together, 67. So now I've got my equation, 0.11x plus 0.15 times x plus 100 equals 67. Let's distribute this guy through, so we get 0.11x plus 0.15x plus 0.15 times 100 is 15 equals 67. Combine like terms, 0.26x plus 15 equals 67. Subtract 15 from both sides, and that gives us 0.26x equals 52. Divide by 0.26, and that gives me x equals 200. And that's exactly what I'm looking for because of the way that I labeled x. X was the total milliliters of solution A that we're using, and that's exactly what we're looking for. So our final answer is 200.